Ms. Radhe, for this introduction. Beginning with this disclaimer, I am no expert in this domain, just a keen learner. Post my retirement from Indian Navy on 30th June 2023, I am now shouldering two very humbling assignments. One as a professor of practice in the Department of Mechanical Engineering of IIT-Madras, and the second as strategic advisor to Codicea Defense Innovation and Atal Incubation Center, which is an initiative of the Niti Aayog. It therefore provides me a great opportunity to bring together best minds from academia, defense R&D and industry to help fulfill the vision of Atmanirbharta in the truest sense. In this backdrop, this opportunity to chair the session on smart and future materials, rare earths and semiconductors has come as a godsend, and I am immensely thankful to Director St. George and CEO IMR for this honor. We are starting this fourth session almost dot on time, which per my watch is 1450 hours. This session comprises four of the most qualified researchers in the field of advanced and future materials, belonging to Indian Rare Earths, Mumbai, DMSRD, Kanpur, CSIR, CMIFR, Dhanbad, and Young Scientist Laboratory on Smart Materials, Hyderabad. I would therefore urge the audience to remain alert and active to glean as much information as is possible after a very sumptuous meal. I would also request the panelists to adhere to the time limit of 15 minutes apiece. This will maximize interaction with the audience and ensure better understanding of this vital topic. A longer interactive session will help in making the audience more aware of the myriad challenges being faced by the combine of the Department of Atomic Energy, DRDO and CSIR laboratories in this niche field. The title of this session also includes semiconductors. I am afraid there is no paper per se on this subject, but those who are interested in this subject should not miss reading Chip Wars by Chris Miller, which not only explains the importance of ICs and semiconductors, or chips as they are called, but also the games that have been played out by advanced nations over the years in cornering breakdown and build up parts, manufacture and sale of chips. In the sessions preceding lunch, we heard experts from the Indian Army and Indian Navy articulate their service requirements for impact absorbing body armor and special materials for modern ship and submarine building. Dr. Samir Kamath, the chief guest in his inaugural address, had impressed upon the inescapable need to mine, design, develop and produce special materials for the country's myriad requirements for the future, now, and make amends for this strange habit which we have perfected of always missing the bus. Therefore, if the need exists and the four vital verticals, namely the consumer, meaning the user, the researcher, meaning the R&D labs and the academia, the industry, meaning the miner and manufacturer, and fourthly, the chief patron, meaning the government of the day, are keen and capable, then all that is needed is for premier think tanks like the St. George to devise a foolproof strategy, pooling the resources of all stakeholders, and push it hard through the corridors of military establishment for quick implementation in the defense forces at least. Now a short word about the papers in session. We will hear the speakers enlighten us on rare earths, smart fibers, smart materials which focus on applications of thermoelectric materials in electronics and infrared cloaking of military vehicles and many more such applications. Contrary to popular belief, rare earths are found in abundance across the world. Even our backyards may contain the tiniest amount, perhaps a few parts per million. Although the rarest of the rare earths is nearly 200 times more abundant than gold. These oxidized minerals are considered to be rare only because most deposits are of very low quality and concentration, making them economically prohibitive to mine. The audience will recall that the widely acclaimed Hollywood movie Oppenheimer had shown how chemical ion exchange procedures were developed by the US scientists for separating and purifying rare earth elements in their quest to build the first atomic bomb, which ultimately put an end to the World War II. The demand for rare earths had skyrocketed following the launch of the first color television sets in the mid 1960s. Over the years, nations have competed to become the leading supplier of rare earths, smart materials, and smart polymers. But, as in other cases, China has steadily strengthened its hold on the world market, largely due to its ability to produce and sell at highly competitive prices. This precarious scenario is the reason enough for St. George to put in place a modus operandi which would compel the establishment to sit up and catch the bull by its horns before we find ourselves pushed into a corner and badly mauled. To set the stage for some very interesting presentations to follow, I invite the first speaker of the session, Shri Anuttam Mishra from Indian Rare Earths Limited, a mini Ratna Cat 1 central public sector enterprise under the administrative control of the Department of Atomic Energy. Shri Mishra.
Good afternoon, ladies and gentlemen. I am from the industry right now, and I am going to speak on advanced material for defense and aerospace industries. Initially, I will brief about our company. Then on the Initially, I will give a briefing about our company. Then the importance of rare earths in our day-to-day lives. The slideshow is not working.
So it is. So you just press this for whichever slide. The slide will be shown on the screen.
Indian Rare Earths, now IRL India Limited, was constituted in the year 1950 and was one of the first PSUs in the country. It was the vision of the Dr. Homi Jehangir Bhabha, and when he established the first setup, he said profit earning was only secondary as against the greater role IRL had to play. Way back in the year 1950, he had understood the importance of rare earths. Now this is the Atomic Energy Program and IRL's position. We are mandated by the Atomic Energy Act 1962. The AMD is our sister concern which carries out exploration, and then mining, processing and refining. The entire ambit of exploitation is carried out by IRL India Limited. Then after refining, some of the strategic materials are given to NFC, which in turn they convert to zirc alloy, and which is used in the atomic nuclear power program of our country. Then the strategic minerals are given to BARC for strategic applications. Now, this is the reason why the entire ambit of mineral sand processing is under the ambit of DE. As you see, as we go from the BSM ore and gradually refine the material, the radioactivity level increases. So that is kept under the ambit of DE. And if you see the mineral processing plant, after the mineral processing, we produce 5 minerals which are free from radioactivity and are given to the customers. Then there is a RE mineral upgradation plant. Then it goes to the RE extraction plant where RE is rare earths are extracted along with strategic compounds. Then it goes for refining, where we produce around 6 rare earths which are there in our sources. This is the overview of IRL. The corporate office is in Mumbai. Our mining and mineral separation plants are located in Chavra, Kerala, Orissa, Ganjam district of Orissa, and in Manavala Kurchi district of Tamil Nadu. The corporate research center is in Kollam, Kerala. Now we have a RE refining plant in Kerala and RE extraction plant in Ganjam. Now the green highlights the new projects which we have undertaken to increase the RE bearing minerals. That is Brahmagiri project in Odisha, a joint venture of IRL, and the Middalam Inayam project in Tamil Nadu. We have initially, very recently set up a RE and titanium theme park in MP, and RE permanent magnet plant in Andhra Pradesh. Now, if we see what are rare earths, it is a group of 17 chemical elements vital to manufacture of high-tech products. Scandium and yttrium tend to occur in the same ore deposits as lanthanides and exhibit similar chemical properties. So they are also called as rare earths. The light rare earths are lanthanum to samarium, and heavy rare earths are gadolinium to lutetium. Now, if you see the rare earths out there, I've circled some of the rare earths in red. Those are the ones which are available in Indian resources. Now, this is a brief about IRL operations at a glance. We have two types of deposits. One is the dual deposit, the other is a placer deposit. So we mine them using manual mining methods, mechanized mining, as well as excavators. Then the mined out sand is pre-concentrated, and then mineral processing carries out where all the 7 minerals are, we produce all the 7 minerals. Then it goes to, then the RE-bearing mineral goes to the rare earth extraction plant, and after extraction of rare earths, the RE concentrate is sent to the RE refining plant for production of refined RE, that is separated high pure rare earths. Now, lanthanum, cerium, neodymium, praseodymium, samarium, gadolinium, and dysprosium, those are available in Indian resources. Now, if you see the global mapping of RE deposits, the Mount Pass deposit in US has about 8.24% REO, but they still do not carry out any refining or extraction activities out there. The biggest producer, China, has a deposit of 6% REO. And the deposit, in addition, contains iron oxide, copper, and gold, making the extraction extremely viable. But in India, we operate at around 0.056 to 0.058% REO in our source, which is 100 times leaner compared to that of China. If you look at the world demand, light rare earths demand is around 1,26,000. In India, it is hardly anything, only 300 tons. And heavy rare earths demand globally is around 5,400 tons. In India, it is minuscule, a few grams. And this is IRL's rare earth portfolio, plus 96 RE-bearing mineral is first produced. That goes to the RE extraction plant. Then individual rare earths are produced. Samarium oxide is produced by IRL. Then that is converted to samarium cobalt alloy based on BRC technology. Then based on technology given by DMRL, it is converted to samarium cobalt magnet. The plant has been set up at BRC complex, Vizag, under the aegis of DAE. Now, coming to heavies, we produce gadolinium and dysprosium, but its content is to the tune of only 1 ppm and 7 ppm in the earth crust. So we have mastered the technology to extract elements available in ppm form. Now, some of the initiatives of IRE in the field of RE is through Automotive Research Association of India, we have developed a 3-way catalytic converter. It is presently under field trial at Mahindra & Mahindra and Varroc Engineering. Then, through our in-house R&D, yttrium stabilized zirconia, containing 8% by wet yttrium oxide in zirconium oxide and lanthanum zirconate. A bilayer coating was applied on Sukhoi 30 engine nozzle by HAL. It withstood complete long-term endurance testing and 100 hours in a test bed of equivalent flying. Similarly, lanthanum zirconate was tested at IGCAR Kalpakam by applying coating on high-density graphite. It withstood 5 thermal cycles at 1500 degrees centigrade. Generally, it withstands two cycles. Our material withstood 5 thermal cycles. So thermal barrier application materials of various grades IRE is able to manufacture. Now, as you may be aware, rare earths free from radioactivity is open to all the private players. But till date, nobody has shown interest in setting up any downstream industries on rare earths. So taking that initiative in order to encourage entrepreneurs, IIT, with the help of BRC, has set up pilot plant facilities for production of metals of lanthanum, cerium, NdPr, then plant for extraction of rare earths from e-waste, and for production of LED and lamp phosphor. These were developed by BRC in gram scale. We have scaled it up to about 10 kg scale each, so that entrepreneurs can come, have hands-on experience in these facilities and develop commercial operations. Now, this is the Retd permanent magnet plant, which was inaugurated by Honorable Prime Minister on the 25th anniversary of the World Technology Day on 11th of May. Now, this plant will be